do something useful, any feedback now or later will certainly be appreciated. And we're starting with our shortest and smallest project, which is the first one that a lot of people end up using. It's this project on Babylonian Numeration. I want to give a brief introduction to what we do. This is something that many of you know, but for some of you is more new. Triumphs as a whole, triumphs, and this acronym on the first page continues to make me happy. Transforming instruction in undergraduate mathematics via primary historical sources. Our goal is to write projects, to use projects, and then to evaluate these projects that teach standard topics in the undergraduate curriculum based on primary historical sources. The rough idea is, instead of spending some number of days lecturing on a topic in group theory or in linear algebra, instead you can give students this project, a project that will cover the same material, that will teach them the same material, but they'll see it from the first person who worked on it. So not only will they learn the mathematics, but they'll hopefully learn some of the humanity behind it. They might see some of the struggle in the people who came up with this for the first time. They will often see mathematics which is familiar, but not completely familiar. The notation or presentation is a little bit different, which can give rise to just enough cognitive dissonance that they have to think in a way they wouldn't during a normal lecture. And if you haven't looked at these lately, I wanted to also put in this brief ad. We have lots of projects available. Projects for, at this point, most classes that undergraduates take beyond campus. The website will take you to detailed descriptions and downloads of any or all of these, but they're all available, and we would love you to use them, and if you use them, love you to share with us your experience. We're still collecting, and most of you have filled these out before, so you know this, but we're collecting implementation reports from all instructors, and we're looking at them to find out how people are using the projects, and then using those reports when appropriate to modify the projects. How does this work in class? Generally, these projects stretch out for a few days, anything between 2 and 10 class days, really, depending on the project. Students will spend time in class working in groups, going through parts of the primary source and trying to complete various tasks. Homework will be sometimes reading, sometimes other tasks, and even more often, I think, writing up their individual solutions to what their group came up with. I mentioned this briefly. This Babylonian Numeration project that I want to talk about briefly today is absolutely the shortest project. It will take no more than 1 class period to finish, often for many people less than 1 class period. And it's by far the least source material. One could argue, in fact, that there's almost no text at all. When I give this, I don't do a lot of introduction. I'll say something like, let's suppose you have a friend who's an archaeologist. She finds this tablet and brings it to you. She doesn't even know what language it's written in, but she thinks it's probably related to math. And you know some math. So let's see what you can figure out. In looking at some of these implementation reports that I mentioned, there are other things that people have done. So at least one person who will give a medium-length introduction to Babylon and Babylonian civilization, roughly where it was and when it was. People have discussed this interesting challenge of translating a text from an unknown language. Someone that talks about the Rosetta Stone in class and seen hieroglyphics for hundreds or thousands of years. But for a long time, nobody in the world knew how to read hieroglyphics, and it had been completely forgotten. The task, therefore, of translating something out of hieroglyphics is very different than the task of translating something out of a language that is known. And there's quite a bit of flexibility here, depending on what you might want to do. All right. The text that they get is this. The picture is a reproduction, really, of a Babylonian tablet. I'll show you the cool photo later, if you like. There's somebody with sound on doing something that sounds like a jar or a knife scraping. If you know who that is, you could mute yourself. Apologies. The text looks like this. There are clearly 3 columns. There's some order to it the students trying to figure out, and they're given these 3 questions. Based just on this picture. Figure out how the numerals work. describe the math that's happening here, and then write a new number. Figure out how to write the number, say 72, using Babylonian numeral. At this point, they've been given zero introduction to Babylonian numeration. They have no idea how any of this works. Hopefully they have no idea how any of this works. That they have exactly this. And they're put in groups and they set to work. What happens? Well, I've done this several times. I've done this in history of math classes, and I've done this in math for future teachers classes. And it follows a pretty predictable pattern over about 15 minutes, where students first look at this and say, we'll never be able to do this. I have absolutely no idea what's going on. They kind of whisper and murmur to each other a little bit, and it's not very long before people start to notice something. And you might guess what they start to notice. If you look down even the first column, the fact that you see first 1 wedge, and then 2 and 3 and 4 and 5 wedges isn't a very big reach for students to come across. They'll probably find that pretty quickly. Using the third column is a little more annoying, in part because it's damaged. The damage, I've had some questions about this. The damage is on purpose. The damage is there because the actual tablet is damaged. And this is often the case. These things, this is a 3,500-year-old tablet. The fact that it survives this well is pretty awesome, and it's not perfect. They have to deal with the fact that it's just not quite perfect. So they'll start to notice these things about the numbers. They'll start to think they know what's going on. After a few minutes, I often have one student who's completely certain they figured it out, and they're usually wrong. So then they back up and try again. And really, in about 15 minutes, most groups have figured out most of what's going on. Usually enough time to get a good sense that if you look at this column here, 9 and 9 is a vertical wedge, 2 horizontals and another vertical. Well, they figure out that this is a 1 and these are 10s pretty quickly. So that left wedge being a 60 maybe is necessary if you at this point have determined that maybe the first column times the second column is the third column. If you haven't seen this before, this is in fact a simple table of squares. The squares from 1 to 12. The 60 is not obvious to them, though. They think it's a bigger number than 50 is the most common guess. Nevertheless, 10 or 15 minutes, most groups are doing this. And at this point, I bring them together and we have a full class discussion. Class discussion about how the numbers work, a class discussion about what they've noticed, and then what else we can do with this. And this is a good place to talk about something that we typically talk about, introducing different systems of numeration. What's good, what's bad, what do you see as useful in this system, and what's maybe less useful. I would point out that people have found different ways to use this. One thing that I haven't done, but I noticed a few people have, and I kind of like, don't give the groups 15 minutes. That can be a long time if you're a little bit stuck. So maybe 3 to 5 minutes. Let's pause everybody. Just ask people to share what they've noticed. Some instructors have suggested students assign names to the different symbols to make it easier to talk about. Beep and boop apparently came up a few weeks ago when someone was using this for the horizontal and vertical wedges. More than one person has reported this is the very first thing they do in a history of math or a math for teachers course, even before the syllabus on day 1 is pass this out, which at least has the benefit of letting students know immediately that they won't be getting lecture 2 for the entire term. Someone has brought Play-Doh to class and some little piece of metal that they can use to put marks in it to demonstrate just how Babylonian numerals work. It's worth noting that this is, if your screen is about the size of my screen, this is pretty close to actual size. This is something like a 4 by 6 inch tablet. These aren't enormous things. They're small, handheld pieces of clay that are wedged and baked. Questions yet?
Yeah, may I interrupt?
Please.
The size of the tablets range from postage stamped to a laptop computer size. So they're not all the same size.
Okay, good.
Often they are, the little round ones are called hand tablets because the students hold them in their hands. That's not one. You have
This is,
Yale tablet 7289 there.
no, this is, I only have the one that this is based on.
Okay, that's fine.
So this is the one from the project, a picture of the real version that's not remade.
Good.
Good. What else you got, Chris?
That's cool.
I hesitate to put this. Let's think about possible problems. Things that can be problems. One, of course, is that if there are students who already know Babylonian numeration, this is a bad project for them. If you have several of those, they probably go in their own group and get something else to do. If you have a lot of those, then the project probably shouldn't be used at all. I usually have about one. It's not very hard for that student to not share with their group mates what's going on. One problem that we see for some of our projects is if a student looks at a text and says they have no idea how to start. If we've designed our tasks and scaffolded things well, this shouldn't often happen. And I find with this project, it doesn't often happen. It does, and I come over and say, well, look at just the first column. Do you notice anything here? And they will almost invariably notice something. It's tempting for students, if they're not used to doing group work, to not want to try in their group. If I just wait, they say, eventually the answer will come to me. And in some sense, that's true even for this project, because I do walk through with them how the numbers work after they figure it out. It's not something we've come across much, partly because I think starting work on this is so tractable that in front of them, it's a little bit interesting. People are talking about it around them, that they're willing to start. I have this picture available for instructors or students. If people want, it's kind of fun to see it sometimes. And that's the whole project. Even if there's a good class discussion and
Can you share that picture?
Yes. I will share it. How shall I share it?
I know, I mean, but the actual picture.
Can you see that?
I can email you and send it back to me, but I really, I mean, just it's helpful when the kids go, I can't see it. Here's the picture. This is why it's a little hard to see. Kind of cool, actually.
Yeah, so I guess what I probably should just do is put this on last page of the project online.
Yeah.
There's no reason this can't just be attached to the PDF.
Yeah.
That's a good idea.
Just, I mean, you know, color picture as the part of the PDF file, because that's really helpful to me to really, and also my other advice is make sure that your copier is pretty decent, because the copy of a bad copy of the copy.
Yes, you can't reproduce this really carefully. Yeah, that gets to be a problem.
Yeah, make sure your copier is doing well, because I have had copier not doing too well, and a bad copy of this is really hard to.
Right, that makes sense.
Actually,
Yeah.
I didn't find that copy very good to begin with.
No, it's not very good. I don't think it's much worse than what we see here, though.
No, I mean the drawing.
Mm.
The picture is very good.
You think the picture is better than the drawing?
Oh, yeah.
Oh.
But I think the students would have real trouble with it.
True.
Yeah.
I have. Yeah, go ahead.
Yeah, I think that it would be nice to have both. I mean, just because you can really see the drawing gives you, you know, is a little easier to see, but the picture really, this is what it really looks like. I think
Right.
that's kind of cool. Like, this is what this really looks like. It's
Right.
really cool, actually.
I will definitely make sure that's available. It wasn't in part because I couldn't find the original picture when I first made the project. But now that I have it, that should absolutely be there. I'm looking at chat and other people are asking for the picture. And then a comment, and I've gotten this before. I don't know who Mogner JS is. Monnier. Are you in a position you can talk to us? Person is muted. Would the project be less effective if we made an easier version to read? People have asked for a really nice version, and LaTeX can make Babylonian cuneiform, so we could make a beautiful table that includes all the information, including what's missing. I don't want to, because I do like the fact that it's hard to read. I like the fact it makes this a little bit more difficult, I think, without being too difficult. So I think I would agree. That was Adam's one who said it might be less effective. I think it would be less effective if it were easy to read, but finding that boundary line is a bit tricky. And if someone disagreed and said they really wanted to make a clean version of this and that's what they wanted to use, I would certainly be up for that.
Hi, I'm Magner.js. I
think it would be cool to have actually the picture as well as the drawing, because then the kids are really, oh, this is really what, here it is, and here's, yeah.
Yes, that makes sense.
I agree.
Go ahead, sorry.
No, that's fine. I was the one who had the comment. I'm Magner.js, now I'm Jody. I put my name up there. And I agree. I think having both would be really helpful so they can see. I mean, we can talk about where it came from, but actually seeing the actual tablet where that image came from, I think is powerful for the students.
That's true. Nice to meet you, by the way.
Nice to meet you. Actually, I've met you in Colorado a couple years ago, but yes.
Sorry.
No, that's okay.
Anyone else who's used this and wants to share experience?
I use it on, I think, the second day of class. Because I do introductory stuff the first day of class, and then the second day of class when I'm talking about numeration, this is the first thing I do.
When I teach numeration, I give them this first, and then other systems, I either have them read about or I introduce. You do the same thing?
Yeah. I do this first, and then Chinese, for some reason. Okay, so for those who don't know, I have like a Chinese project, so it's, for some reason I know a little bit about Chinese rod arithmetic. I don't know how that happened.
We have other questions coming in. Do you tell students the markings are numbers or just that it contains math? I haven't told them that it contains, that they're numbers. But I've never, I feel like they've usually started there. Our baseline assumption is if it's math, they're probably numbers. And then a suggestion from Emily. Hello, Emily, welcome. I don't know if everyone can see this text. Mapping or drawing the tablet's symbols out on the board after students have a chance to struggle with a picture or the drawing can help with understanding and seeing better what's happening. This can be student-led. So you're suggesting that they sort of redraw it in big, nice symbols on the board?
Cool.
I imagine that indeed could be a really nice way to do this.
Yeah, I use this on the first day of class. And on our Friday, I take our kids to our art building, and they have to make their own out of clay.
That you have like a wedge tool?
Yeah, our instructors have a bunch of wedge tools, and then we give them a different assignment. They have to make a table of cubes rather than squares.
Wow.
Cool.
Is there any, this sounds fun. Yeah, is there any difficulty in getting the clay or access to it?
No, our art instructor is he's very gracious. He rolls out the slabs. He shows the students how to do it. And they just roll out the slabs, and then they make their own tablets, and then he actually fires them for us, and about 3 weeks later they have a class souvenir.
Wow.
That's cool.
I'm going to talk to our art people now. That's kind of awesome.
Yeah, it went really well, and they really learned the sort of the way it worked a lot more than, I mean, this was great on the first day, and we did that, and then we did numeration systems on the second day of class, and then the third day we went to the art building. So they had a little bit of extra practice by that point. but it worked well.
Wow.
Cool.
Were the students surprised how difficult it was to make neat numerals?
Yeah. Yeah, they got a newfound appreciation for our homework. You know, I said, look, you don't have to do the rest of them in clay, so don't complain about it.
Chris, do you see the chat that's coming up?
Yeah. Well, if I click on it, I do.
Okay, I don't know if everyone's watching this. You've been asked by Jody to share more details about the creation of the tablets. Have you ever written this up?
Yeah, I think I have a written file on I'm at home now, but on my work computer, I think I have a LaTeX file that I've typed up for the assignment. But yeah, I just have them. I arrange it with the art teacher first, and he has clay ready for us, and then we get it rolled out. He likes to show the students how to do it. We're a small school, so we can kind of do this kind of stuff. And then our class is actually split into two groups. We have majors and non-majors, and we're a travel class.
A travel class?
Yeah, we go to Italy and Greece.
Wow.
And
Is it history of math class?
it's a history of math with a travel component at the end of the
Okay.
semester.
Okay.
So we use it almost as a group bonding experience as well, because they have to work together, and we mix up the students between the majors and the non-majors, and they each have different assignments. So the majors have to do a table of cubes and fit it on the tablet, and the non-majors basically reproduce this tablet with obviously the missing parts present.
Cool. So are you comfortable with sending me what you've written up about this? And I will
I can do that. Absolutely.
If I can find a way to get an email list of everybody who's in this webinar now, I will send it just to you. And if I can't, I'll just send it to the big group.
Yeah, I can do that.
Huh. And Cynthia gives us a recipe for cuneiform cookies in the chat. That's
Now
funny.
there's an idea, huh? Uniform cookies.
Cynthia, who I assume is muted, also pointed out, I like this. This starts off a history of math class by looking at detective work, which is a wonderful chance maybe to remind students that people are doing research in the history of mathematics and are still discovering more. And at one point, somebody was the first person to figure some of this out. He's waving. If not, lots of people have finals to grade and things to do, so we will sign off. Thank you for coming to our experiment, and if you found this useful, let me know, and we will have more conversations after the new year. But thank you.
Thank you.
Thank you.